Lee Smolin is an American theoretical physicist, a faculty member at the Perimeter Institute for Theoretical Physics, an adjunct professor of physics at the University of Waterloo and a member of the graduate faculty of the Philosophy Department at the University of Toronto. Smolin is best known for his contributions to quantum gravity theory, in particular the approach known as loop quantum gravity. He advocates that the two primary approaches to quantum gravity, loop quantum gravity and string theory, can be reconciled as different aspects of the same underlying theory. His research interests also include cosmology, elementary particle theory, the foundations of quantum mechanics, and theoretical biology. Early life: Smolin was born in New York City. His brother, David M. Smolin, became a professor in the Cumberland School of Law in Birmingham, Alabama. Education and career: Smolin dropped out of Walnut Hills High School in Cincinnati, Ohio, and was educated at Hampshire College. He received his Ph.D. in theoretical physics from Harvard University in 1979. He held postdoctoral research positions at the Institute for Advanced Study in Princeton, New Jersey, the Kavli Institute for Theoretical Physics in Santa Barbara and the University of Chicago, before becoming a faculty member at Yale, Syracuse and Pennsylvania State Universities. He was a visiting scholar at the Institute for Advanced Study in 1995 and a visiting professor at Imperial College London before becoming one of the founding faculty members at the Perimeter Institute in 2001. Theories and work. Loop quantum gravity Smolin contributed to the invention of loop quantum gravity in collaborative work with Ted Jacobson, Carlo Rovelli, Louis Crane, Abhay Ashtkar and others. LQG is an approach to the unification of quantum mechanics with general relativity which utilizes a reformulation of general relativity in the language of gauge field theories, which allows the use of techniques from particle physics, particularly the expression of fields in terms of the dynamics of loops. With Rovelli he discovered the discreteness of areas and volumes and found their natural expression in terms of a discrete description of quantum geometry in terms of spin networks. In recent years he has focused on connecting LQG to phenomenology by developing implications for experimental tests of space-time symmetries as well as investigating ways elementary particles and their interactions could emerge from space-time geometry. Background: independent approaches to string theory. Between 1999 and 2002, Smolin made several proposals for the still open question of giving a fundamental formulation of string theory that does not depend on approximate descriptions involving classical background spacetime models. Experimental tests of quantum gravity. Smolin is among those theorists who have proposed that the effects of quantum gravity can be experimentally probed by searching for modifications in special relativity detected in observations of high-energy astrophysical phenomena. These include very high-energy cosmic rays and photons and neutrinos from gamma-ray bursts. Among Smolin unregistered trademark contributions of a co-invention of doubly special relativity and of relative locality. Foundations of quantum mechanics. Smolin has worked since the early 1980s on a series of proposals for hidden variables theories, which would be non-local deterministic theories which would give a precise description of individual quantum phenomena. In recent years, he has pioneered two new approaches to the interpretation of quantum mechanics suggested by his work on the reality of time, called the real ensemble formulation and the principle of precedence. Cosmological natural selection. Smolins' hypothesis of cosmological natural selection, also called the fecund universes theory, suggests that a process analogous to biological natural selection applies at the grandest of scales. Smolin published the idea in 1992 and summarized it in a book aimed at a lay audience called The Life of the Cosmos. The theory surmises that a collapsing black hole causes the emergence of a new universe on the other side, whose fundamental constant parameters may differ slightly from those of the universe where the black hole collapsed. Each universe thus gives rise to as many new universes as it has black holes. The theory contains the evolutionary ideas of reproduction and mutation of universes, and so is formally analogous to models of population biology. the resulting population of universes can be represented as a distribution of a landscape of parameters where the height of the landscape is proportional to the numbers of black holes that a universe with those parameters will have. Applying reasoning borrowed from the study of fitness landscapes in population biology, one can conclude that the population is dominated by universes whose parameters drive the production of black holes to a local peak in the landscape. This was the first use of the notion of a landscape of parameters in physics. Leonard Susskind, who later promoted a similar string theory landscape, stated, "I'm not sure why Smolin's idea didn't attract much attention. I actually think it deserved far more than it got." However, Susskind also argued that, since Smolin's theory relies on information transferred from the parent universe to the baby universe through a black hole, it ultimately makes no sense as a theory of cosmological natural selection. According to Susskind and many other physicists, the last decade of black hole physics has shown us that no information that goes into a black hole can be lost. Indeed, the debate over this issue has been resolved with Stephen Hawking, the largest proponent of the idea that information is lost in a black hole, reversing his position. In this light, information transferred from the parent universe into the baby universe through a black hole is not conceivable. Smolin has noted that the string theory landscape is not proper falsifiable if other universes are not observable. This is the subject of the Smolin-Susskind debate concerning Smolin-unregistered trademark S argument. The anthropic principle cannot yield any falsifiable predictions, and therefore cannot be a part of science. There are then only two ways out: traversable wormholes connecting the different parallel universes, and signal non-locality, as described by Anthony Valentini, a scientist at the Perimeter Institute. In a critical review of the life of the cosmos, astrophysicist Joe Silk suggested that our universe falls short by about 4 orders of magnitude from being maximal for the production of black holes. In his book Questions of Truth, particle physicist John Polkinghorne puts forward another difficulty with Smolin's thesis: one cannot impose the consistent multiversal time required to make the evolutionary dynamics work, since short-lived universes with few descendants would then dominate long-lived universes with many descendants. Smolin responded to these criticisms in Life of the Cosmos, and later scientific papers. When Smolin published the theory in 1992, he proposed as a prediction of his theory that no neutron star should exist with a mass of more than 1.6 times the mass of the Sun. Later this figure was raised to 2 solar masses following more precise modeling of neutron star interiors by nuclear astrophysicists. If a more massive neutron star was ever observed, it would show that our universe's natural laws were not tuned for maximal black hole production, because the mass of the strange quark could be retuned to lower the mass threshold for production of a black hole. A 2 solar mass pulsar was discovered in 2010. In 1992 Smolin also predicted that inflation, if true, must only be in its simplest form, governed by a single field and parameter. Both predictions have held up, and they demonstrate Smolin-unregistered trademark S main thesis, that the theory of cosmological natural selection is proper falsifiable. Contributions to philosophy of physics equals, Smolin has contributed to the philosophy of physics through a series of papers and books that advocate the relational, or Leibnizian, view of space and time. Since 2006, he has collaborated with the Brazilian philosopher and Harvard Law School professor Roberto Mangiabeira on the issues of the reality of time and the evolution of laws. In 2014 they published a book, its 2 parts being authored separately. A book-length exposition of Smolin's philosophical views appeared in April 2013. Time Reborn argues that physical science has made time unreal while, as Smolin insists, it is the most fundamental feature of reality. Space may be an illusion, but time must be real. An adequate description according to him would give a Leibnizian universe. Indiscernibles would not be admitted and every difference should correspond to some other difference, as the principle of sufficient reason would have it. A few months later a more concise text has been made available in a paper with the title Temporal Naturalism. The Trouble with Physics, Smolin's 2006 book The Trouble with Physics explored the role of controversy and disagreement in the progress of science. It argued that science progresses fastest if the scientific community encourages the widest possible disagreement among trained and accredited professionals prior to the formation of consensus brought about by experimental confirmation of predictions of falsifiable theories. He proposed that this meant the fostering of diverse competing research programs, and that premature formation of paradigms not forced by experimental facts can slow the progress of science. As a case study, The Trouble with Physics focused on the issue of the falsifiability of string theory due to the proposals that the anthropic principle be used to explain the properties of our universe in the context of the string landscape. The book was criticized by the physicists Joseph Polchinski and other string theorists. In his earlier book Three Roads to Quantum Gravity, Smolin stated that loop quantum gravity and string theory were essentially the same concept seen from different perspectives. In that book, he also favored the holographic principle. The Trouble with Physics, on the other hand, was strongly critical of the prominence of string theory in contemporary theoretical physics, which he believes has suppressed research in other promising approaches. Smolin suggests that string theory suffers from serious deficiencies and has an unhealthy near monopoly in the particle theory community. He called for a diversity of approaches to quantum gravity, and argued that more attention should be paid to loop quantum gravity, an approach Smolin has devised. Finally, The Trouble with Physics is also broadly concerned with the role of controversy and the value of diverse approaches in the ethics and process of science. In the same year that The Trouble with Physics was published, Peter Woit published a book for non-specialists whose conclusion was similar to Smolin's, namely that string theory was a fundamentally flawed research program. Views: Smolin's view on the nature of time. More and more, I have the feeling that quantum theory and general relativity are both deeply wrong about the nature of time. It is not enough to combine them. There is a deeper problem, perhaps going back to the beginning of physics. Smolin does not believe that quantum mechanics is a final theory. I am convinced that quantum mechanics is not a final theory. I believe this because I have never encountered an interpretation of the present formulation of quantum mechanics that makes sense to me. I have studied most of them in depth and thought hard about them, and in the end I still can't make real sense of quantum theory as it stands. In a 2009 article, Smolin has articulated the following philosophical views: there is only one universe. There are no others, nor is there anything isomorphic to it. Smolin denies the existence of a timeless multiverse. Neither other universes nor copies of our universe within or outside exist. No copies can exist within the universe, because no subsystem can model precisely the larger system it is a part of. No copies can exist outside the universe, because the universe is by definition all there is. This principle also rules out the notion of a mathematical object isomorphic in every respect to the history of the entire universe, a notion more metaphysical than scientific. All that is real in a moment, which is a succession of moments. Anything that is true of the present moment. Not only is time real, but everything that is real is situated in time. Nothing exists timelessly. Everything that is real in a moment is a process of change leading to the next or future moments. Anything that is true is then a feature of a process in this process causing or implying future moments. This principle incorporates the notion that time is an aspect of causal relations. A reason for asserting it is that anything that existed for just one moment, without causing or implying some aspect of the world at a future moment, would be gone in the next moment. Things that persist must be thought of as processes leading to newly changed processes. An atom at one moment is a process leading to a different or a changed atom at the next moment. Mathematics is derived from experience as a generalization of observed regularities, when time and particularity are removed. Under this heading, Smolin distances himself from mathematical Platonism, and gives his reaction to Eugene Wynne as the unreasonable effectiveness of mathematics in the natural sciences. Smolin views rejecting the idea of a creator as essential to cosmology. He also opposes the anthropic principle, which he claims cannot help us to do science. He also advocates a principles for an open future which he claims underlie the work of both healthy scientific communities and democratic societies, a 1, When rational argument from public evidence suffices to decide a question, it must be considered to be so decided. When rational argument from public evidence does not suffice to decide a question, the community must encourage a diverse range of viewpoints and hypotheses consistent with a good faith attempt to develop convincing public evidence. Publications. The following books are non-technical, and can be appreciated by those who are not physicists. 1999. The Life of the Cosmos, ISBN 0195126645, 2001. Three Roads to Quantum Gravity, ISBN 0-465-07835-4, 2006. The Trouble with Physics, The Rise of String Theory, The Fall of a Science, and What Comes Next. Houghton Mifflin. ISBN 978-0-618-55105-7, 2013. Time Reborn, From the Crisis in Physics to the Future of the Universe. ISBN 978-0-547511726, 2014. The Singular Universe and the Reality of Time, A Proposal in Natural Philosophy by Lee Smolin and Roberto Mangiabeira, Cambridge University Press, ISBN 978-1107074,064. Awards and honors. Smolin was named as number 21 on Foreign Policy magazine's list of top 100 public intellectuals. He is also one of many physicists dubbed the new Einstein by the media. The Trouble with Physics was named by Newsweek magazine as number 17 on a list of 50 OE books for Artemia June 27, 2009. In 2007 he was awarded the Majorana Prize from the Electronic Journal of Theoretical Physics, and in 2009 the Klopsteg Memorial Award from the American Association of Physics Teachers for OE Extraordinary Accomplishments in Communicating the Excitement of Physics to the General Public. He is a Fellow of the Royal Society of Canada and the American Physical Society. In 2014 he was awarded the Buchalter Cosmology Prize for a work published in collaboration with Marina Corta. Personal life. Smolin was born in New York City, USA. His father is Michael Smolin, an environmental and process engineer, and his mother is the playwright Pauline Smolin. Lee Smolin has stayed involved with theatre, becoming a scientific consultant for such plays as A Walk in the Woods by Lee Blessing, Background Interference by Drusilla Cornell, and Infinity by Hannah Moscovich. He is married to Dinah Graha, a lawyer and public servant in Toronto. His brother is law professor David M. Smolin. References. External links: a partial list of Smolin's published work, a debate of the merits of string theory between Smolin and Brian Greene, from National Public Radio, The Unique Universe. Smolin explains his skepticism. Read The Multiverse, Closer to the Truth, series of interviews by Smolin on fundamental issues in physics. Time Reborn, A New Theory of Time, A New View of the World on YouTube. Smolin's presentation at the Royal Society of Arts, Lee Smolin at the Mathematics Genealogy Project.